Welcome students. In this video, we will be discussing how to count nodes in circular linked list. Actually, we were discussing about how to delete a node in circular linked list, but there we require the length of circular linked list to be known to do validation. Because in deleting, we receive position, and that position should not be outside the length of linked list. If it is so, then we should not we should just simply say that it is invalid input. So to validate the value of POS position in deletion of a node in circular linked list, we want to find the length of the linked list. So we are now about to see how to count nodes in circular linked list. That's length of circular linked list. So we'll get started. So we have taken a circular linked list here. Okay, how to find the length? First node, second node, third node, fourth node, fifth node, and after fifth node it is again connected to first node. So you take a pointer, keep on moving it, keep on traversing it in the linked list. At some point of time it again reaches first and meet the pointer first. So at that point of time you can just stop, and in between, whenever you visited a node, you should have incremented. Okay, whenever you have visited a node, you should have counted that node as well with the help of a variable. So I'll tell you. First of all, let me take a pointer called as temp. Initially temp is pointing to first. What I should be checking, that new pointer should not be again equal to the same the address of it, should not again reach the same first node. If it is reaching the same first node, which means a complete cycle is over, so we should stop the process. But that cannot be the right condition, because temp not equal to first. Initially temp is equal to first. So how to do it? With the help of do while. I think previously the same concept. So when it is coming to circular linked list, in many places we are using do while. The reason is, initially the condition temp and first are both equal, so I should first of all perform do block, and then I will check. So first I need to do some process, then only I have to go for checking. So that's the reason we are going to use do while. So now, moving this pointer temp to the next node. Before moving the pointer temp to the second node, let us have a variable called as count initialized to 0. Whenever you move a pointer from one node to next node, before moving it, you increase the value of this count, and then you just move it. So after increasing the value of count, I'm just moving it. Now, after doing the process, I will go for checking do while. Is it temp and first equal? No, temp and first is not equal now. Okay, so I can continue. So now I'm going to move from second node to third node. Before the process, I need to increase the count. So count is equal to 2, and after count is equal to 2, then I will just move pointer temp to next node. Again, condition, is it temp equal to first? No. So you have to move this pointer to next node, but before that you should increase the value of count. Count will become 3, and now you can move your temp to fourth node. Now also temp is not equal to the address of first node, so you can just continue moving to fifth node. Before that you should increase the value of the variable count. Count is equal to 4. Okay, now after incrementing the value of count, I can now move my pointer temp. Still temp and first is not equal, so I can first increment the count value, and then I can move temp to next position. What is the next one? Having address 200, so it will again come here. Now tell me, is that first node and the temp is pointed to same node? Yes. Now first node and temp is same now. First pointer and temp is now same, so that I have to stop the process because condition becomes false. And when condition becomes false, what is the value of count? 5. That 5 is the length of the linked list. So totally 5 nodes are available here in the circular linked list. So count is equal to 5. Okay, fine. So let us write a piece of code, iterative piece of code for doing the same process. Okay, I'll tell you now. So now we'll just start with the count node. Okay, so this is going to be integer. It will be returning the length value. Okay, this function is going to return the length. So integer, let it be count node. Okay, count nodes in CLL. So count node CLL, circular linked list, and it want to take only the address of the first node. So I'll have a argument which is going to take the address of the first node. So struct node start first. Entering inside, first thing what I will do is I will take one more pointer. For example, let me take temp. So this is for traversing purpose. I'm not going to change the pointer first. Let it be in the first node itself. Let me take a new pointer for traversing. Okay, so temp is equal to address of the first node again. So what we have to do now, we have to write a do while block, because first of all, if I write the function, if I write the condition while temp not equal to null, okay, oh sorry, while temp not equal to first, if I write a condition like this, it is false at the very first time itself because temp is already equal to first. So this condition should not be given at this time. So I'll go with the do block now. So do block, inside do block, what you will be doing, I will be first of all having one more variable. I need to say that I will be having one more variable called as count, integer variable called as count. Let me initialize it to 0. And inside your do block, first of all I will increment before moving temp from one node to another node. I will first of all increment the value of count, and then I will move temp from one node to the next node. So it will be temp is equal to temp of next. It is temp is equal to temp of next. So the do block is completely executed. Now after finishing do, now comes the while condition, temp not equal to this. So first do this process and then you just come here for the come here for condition checking, temp not equal to first. Suppose if this condition becomes false, then you have to end up all the process and you can just come outside, and whatever is the value of your count variable now will be the length of the linked list or the total number of nodes available in the linked list. So return the value of count, return count, then the close curly braces are the function. So this is a procedure for finding the total number of node available in a circular linked list. Okay, so this is the iterative approach. Let us also go with the recursive approach of the same also. We will convert it. So it is going to be integer return type. Let us take count nodes CLL. It is going to be recursive, right? So let us add one R. Okay. It is going to take two arguments. First of all, struct node star first is for storing the address of the first node. We'll take one more pointer temp. So I declared it inside the block for iterative method, but I'm going to take it as a argument itself here in it's a temp. Okay, sorry, temp. I'm going to take it as an argument itself. Yes. Both will be taking the address of the first node initially. And I want a variable called as count initialized to 0. But since we are going to write a recursive code, whatever we write inside will be executed for multiple times. Whenever a call is made, whatever you write inside will be executed. So if I write int count equal to 0, every time count variable will be, whenever you make a recursive call, count will be reinitialized to 0, which is not fair. I want it to be done only for the first time of entry. So which will be taken care with the help of static keyword. So whenever you create a static variable, only that statement, that like declaration or initialization will be done at the first calling time only, first calling time of the function. So static int count is equal to 0. Yes. Now what we should do? Okay, now the next thing is, I should first of all do the process first time. For only the first time, I should do the first process, and then I have to check for the condition. How to make it possible here in a recursion? Already I have just we have discussed about this. Let me take a static variable called as flag and initialize it to 0. Now I will check if flag equal to 0, flag equal to 0, or otherwise temp not equal to first. I am going to check for this condition. The reason is, for very first time temp definitely will be equal to first, the condition will become false first time. But that time, in order to override that condition, I place something called as flag variable, initialize it to 0. When it is initialized to 0, then at least this flag equal to 0 will be true for the very first time. So this condition is false, but this condition is true. So I enter, and I first of all do whatever is done here. I will do whatever is done here. Okay. So what is the first thing I will do? I will increment count. And the next one is changing temp to temp of next. Whenever argument value is getting changed, we need to place a recursive call instead of that place. So our count nodes CLL will be called, and first will take the same argument first, but temp will be taking temp of next, because this is literally like temp equal to temp of next, whatever we have done here. Okay, so I'll close parenthesis semicolon. But one more thing, I enter inside. Before counting, I should do one more thing also. I will be simply changing the flag value to I'll be changing flag value to 1, because next time if I enter, this flag should be set to 1. So which means that it should become a false condition. So only first time of entry this will become a true condition. After that it will become a false condition. The reason is, only for the first time I wanted to override this temp not equal to first condition, because first time I want to go with the do block, which will not even it will not be checking any condition first time of execution. Okay, so for that only we are introducing this flag. Okay, so first time this flag will become 0, but after that this will completely a false condition. So if this condition is true, then we will proceed. If this condition becomes false, then we will stop the process. Okay, fine. So now suppose if this condition becomes false, what you will do? When this becomes false, whatever is the present value of count, I will return it. Okay, but I think I don't want a else statement to be given, because if else statement is given, only in the topmost activation area this will be working. But I just simply leave it as it is, a simple statement after if condition. This return statement will be executed. In all the activation record, because in every activation record the process will stop at this recursive line. So all the codes after the recursive call have to be executed for every activation area to get deleted. So this is outside if condition needs to be executed. So here count is a static variable. So in every activation area it will be same only. It is not going to change, because static variable are not created inside the activation record. It is created in the code section. So that is like a global variable. That's a global variable inside a function, inside a block. So you need not to worry that count will be, once if it is changed in the code section, even if you delete and come back to the bottommost activation record, count is not going to change. So in every activation record, this return count will be executed. Finally, it will reach to the main function or any other function where you are calling this r count node cll recursive code. Okay, so that reason I'm just giving this. Okay, fine. So this is a recursive procedure of counting nodes in a circular linked list. So iterative approach of doing the process and recursive approach of doing the same have been completely discussed, right? So the next video we will get into the implementation of deleting a node from circular linked list with the help of this counting nodes, right? Fine. Thank you, students.